7.2 is still about estimate the parameters, but this time we gonna estimate the population mean. So we will still talk about 3 points. The first one, we want to talk about the point estimate. Next, maybe we will talk about what's the confidence interval. After that, we need to know how to get the sample size. So point estimate for the population mean mu is the sample's mean, x bar. X bar is the best point estimate. The reason is just the same reason as the last chapter, because X bar is the best, is the unbiased estimate. So this one is easy to understand, right? Point estimate is a single value, so we just use the X bar to point estimate the mu. And the confidence interval, again, we still need to use a range, an interval to estimate the true value mu. We still use the interval. So the last topic is still need to find the sample size, the minimum sample size we need to do the estimating. So let's check the how to construct the confidence interval, because we already know how to get the point estimate, right? X bar is the point estimate. But when we talk about the confidence interval, we have two different situations. One is called sigma is not known. Sigma is not known. If sigma is not known, we can do the confidence interval. If sigma is known, we have another way to do the confidence interval. But we will say most of the cases, it's almost impossible to get the sigma value for the population. It's almost impossible, because if we want to get the standard deviation from population, which means we need to know each single value in the population, which is almost impossible. So here, all the notations are very familiar to us, right? The mu is, again, the population mean. N is always the sample size. X bar is the sample mean. E here is also called the margin of error, but this time the margin of error is not the same one as the previous section. We have different formula. But again, sample standard deviation is still used S to denote. Of course, just like doing the estimating for proportion, for mean, we also need to check the requirement. And this time, is still to be the simple random sample, and remember this requirement. Either condition is qualified. Normal distribution for the original population or n is greater than 30. So this is the same requirement for central limit theory. We need to get the margin of error too. But how can we get margin of error? We need to use this formula for this case, and sigma is not known. Sigma is not known, then we have a new notation here. It's called T sub half alpha. We have T. Make sure you understand here, it's not Z. Z is for standard normal distribution, and Z distribution is a normal distribution with mu equal to 0. Sigma is equal to 1. But in this case, sigma is not known. We could not use Z distribution because sigma is not known. So we will introduce another distribution called the T distribution. Then we use the T value as our critical value. But the confidence level is still 1 minus alpha. Confidence level is still 1 minus alpha. And another important thing is when we try to use the t-table, we have a new value we need to check. It's called the degrees of freedom. Degrees of freedom, and it is n minus 1. So if the sample size is 10, then n is 9. If sample size is 100, then n is 99. So that's degrees of freedom. Remember, when we check z-table, we do not use anything about degrees of freedom. But for the t-table, we must check degrees of freedom. So critical value t, make sure you understand here, it's still sub-half alpha, not alpha. And another important value we need to check is n minus 1. Round-off rule 3, I think it's still 3 significance level. Oh, it's 1 more decimal places than original data. Let's see what is student t distribution, because it's a new distribution, right? This one is still a normal distribution. Student t is still a normal distribution, but this normal distribution has some important property. From this formula, you will realize the mu of this distribution is still the mu, but the standard deviation of this distribution is not the sigma or sigma divided by square root m. It's s. It's from sample, because we do not know the value of sigma, then we will use the value of s, sample standard deviation. So the denominator part will be s divided by square root of m. That's the distribution of student t. We also need to check n minus 1 as our degrees of freedom. So this time, I will post another table called the table A3. That's our t-table. I will also post the t-table to the content. If you do not have your t-table in your textbook, you can check my content to print out the t-table, because we will use the t-table to find the confidence interval for the mean value. So you can see these are the curves of student t distribution with different degrees of freedom, but all of them are normal curve, bell-shaped curve. So check some properties. Bell-shaped curve. Okay, and wider distribution, small samples. So n is smaller, then the curve will be wider. If the n is greater, then the curve will be narrow. So the mean is still equal to 0. But the standard deviation is not equal to 1. It's greater than 1. Okay? Mean is still 0, but the standard deviation is not like the z-table. It's greater than 1. And the n gets larger, then the t distribution will be very close to the z distribution. If n goes into infinity, then the t-distribution will be just like the c-distribution. So we need to always check the requirement. Normal distribution or sample size greater than 30. Simple random sample, right? So after that, we can use technology or use the table. So our class, we will check the t-table to find the critical value, t sub half alpha. But the t-table is not the same table as the c-table. We will check it later. After that, we got to the critical value. We use critical value and this formula to get what's the margin of error. After that, we can list our confidence interval into this form. It's just the same format as the previous one, p-hat. Point estimate minus margin of error. Point estimate plus margin of error. This time the point estimate is x bar. So x bar minus e, x bar plus e. But the e is not the same thing as the e in last section. It has the new formula, right? So round the same number decimal place for sample mean. So that's the one more decimal places than the original data. Let's check this example. So first we should know how to find the critical value, right? We still need to use the confidence level to find the alpha value. Then we also need to check the degrees of freedom. Remember, degrees of freedom is n minus 1. Then we can check the t-table. So first, we know degrees of freedom is 14. And we know confidence level is 95%. So we can get alpha is 5%. So half alpha. Again, we need to focus on half alpha. Half alpha is 0.025. Then we can check the t-table. If you have the t-table with you, let's check the t-table together. This time, the left column of the t-table just shows you different degrees of freedom. And we have the first two rows on the top. It says area in one tail or area in two tail. Please just check the first row, area in one tail. So here, one tail is right tail. See, it's 0.025. So we check the top row to find which column is for 0.025. And use the left column degrees freedom to locate the critical value. So area in one tail, we check this one, the top row, the very top row, and we find we have 0.025. So this column is what we want. Then we use the degrees freedom 14. After that, we can get the critical value t. The remaining part, we only need to use the critical value plug into the formula to get the margin of error if we need to construct a confidence interval, right? The critical value is just for the margin of error. And for this two formula, it's very similar to the last section. We use the sum of upper limit and the lower limit divided by 2 to get the point estimate if we are only given the confidence interval. So we can use confidence interval to get the margin of error and the point estimate by using these two formulas. It's just the same formula as last section. So the next topic is just the sample size problem. Sample size, here we will use all of the notation are just the same. The sample size here, I will write this formula for you. Let me see what is the correct formula here. It will be, but no matter sigma is known or unknown, we should always use sigma. We should always use Z as the critical value when we talk about the sample size. When we talk about the sample size, we always need to use the Z as our critical value. But when we do the confidence interval, sometimes we should use Z, sometimes we should use T. It depends, right? But for the sample size, the critical value is always the Z. Is always the always the Z. Let me see. Yeah. C score. This critical value always need to be used to estimate the. So I will rewrite it. C sub half alpha. For the sample size again, we always use Z. No matter for the sigma is known or sigma unknown. So if n is not a whole number, always round up to next larger number. So sometimes we do not know sigma, so we just use range over 4 to get the sigma. Or sometimes we will use the S to replace the sigma. Or we will just estimate the value of sigma by using some earlier study. So that's depends on the previous knowledge. Several ways to get the sigma, because most of the time we cannot know the sigma value. So let's check this problem. If we want 95% confidence level and within 3 IQ points, within 3 IQ points means the error, maximum error is 3 points, right? So we check the formula. It's just C sub half alpha. Again, it's C sub half alpha divided sigma. Because we already know C alpha here is 0.05, so C sub half alpha is still C sub 0.025. It's the special one, 1.96. I hope you can memorize that one. 1.96 times 15. How can we get 15? We assume sigma is equal to 15. This one is based on the previous knowledge, so we use this one. And the maximum error is 3 points, so we put 3 here. This is how we get 97. Always round up to next whole number. So we will need 97 students to do the survey, to do the research. Okay. Let's see. Another case is called sigma is known. This situation is very rare, because I say we need to get each value of the sample. Then we can know the sigma, right? Oh, not each value in your sample, each value in your population. Then we can get the sigma value. So this is really rare. But if it's the case, we will not use the previous formula to get the margin of error. Remember, previous...
Yuchen,
previous margin of error, we use T, not Z. We use S, not sigma. But if we know the value of sigma, then we should use sigma. If you use sigma, you need to use Z. You need to use Z. Again, if you use the value of sigma, then you use Z to get the margin of error. So the remaining part is just the same. We get the point estimate, we get the margin of error, then write point estimate plus minus margin of error. So let's check this example. If we know the sigma, this time we know sigma is 2.9. And we also know what's X bar. X bar is our point estimate. So the only thing is we need to find the margin of error, E. So we can skip the requirement check. Again, this time we have sigma, so we use Z. We do not check T table. We use Z table. Z table, for this case, 95 confidence interval, alpha equals 0.05, half alpha equals 0.025. I hope you can memorize this critical value. And we know it's sigma value, so this is Z value divided by the square root of n. We get margin of error. We need to get the margin of error to get the confidence interval. Point estimate minus point estimate plus. So we round up this is our confidence interval. So let's say more realistic situation is sigma is unknown. So we will focus on how to check the critical value T when we do the estimating of mu. Most of the case, sigma is unknown. So if sigma is unknown, we use T distribution. Sigma is known, use C distribution. If it's not normal distributed, or so we ignore this part. We only need to know sigma is known, we use T. Sigma is unknown, use T. Sigma is known, use Z. So that's all for the 7.2. So in 7.2, we have the new distribution called the T distribution. For most of the case, sigma is unknown. So this is the most important part. The format of the confidence interval is just the same as the previous section. Point estimate plus minus margin of error.